What's happening? Hello world, this is Johnny DeLuca and welcome to your 15th SQL Server tutorial. Today I'm going to be showing you how to change some index options using SQL Server Management Studio as well as using T-SQL. So to start, go ahead and connect to an instance of SQL Server. And then once you are connected, we're going to expand the databases folder right here. And we're going to expand AdventureWorks 2012. And we're going to expand the tables folder. Now we're looking for dbo.database log tables right here. We're going to expand this guy. Now we're going to go down and expand the indexes. Now we're going to right click on this one right here, CIX_database log _ host time clustered. We're going to go down to properties and click on that. And once we are here in the properties, we're going over to the select a page pane over here. We want to go to options. And then over here, sort in temp database, we're going to change this to true. Alright. Now, fill factor, we're going to change this from 0 to 80. And then pad index, we're going to set this guy to true as well. Alright, now once we've accomplished all that, we're going to click OK. To apply changes, the index will be rebuilt. OK again. And there I've just shown you a brief example of how to make changes to an index using SQL Server Management Studio. Now I'm going to show you how to do the same thing using a T-SQL script. As always, please copy this down, save it. You can use it later. We're going to run this script. You're going to use AdventureWorks 2012. It's going to be on that same one that you saw we just went through. It's right here. We're going to do we're doing the exact same thing, but this is doing it using T-SQL. Going to hit execute. Commands completed successfully. Alright, pretty cool, huh? Okay, now I just want to talk to you real briefly about fill factor and pad index. As we saw, we went here, we went to properties, we went to options, and we saw here fill factor, pad index. And so the most common option is fill factor. If you think about the name of the option, you can almost derive its purpose. Each data page on the leaf level of a clustered index holds a maximum amount of data, approximately 8,060 bytes. There are some variances, but describing them is beyond the scope of this tutorial. Fill factor tells SQL Server how full the leaf level pages of the index should be when rebuilding or reorganizing an index. Rebuilding and reorganizing an index are part of an index maintenance and will be discussed later in a different tutorial. Managing and maintaining indexes and statistics. That's the tutorial I'll be doing. So, if you do not specify a fill factor during index creation, it will be 100. This means the data pages will be completely full. When the data changes through insert, update, or delete operations, then the page will have to change, or as we say in the database world, split. When a page splits, 50% of the data will be on one page and 50% will be on the other. A few page splits are not too bad, but if this is a regular occurrence, the performance of your database might suffer. While the explanation of how to determine what a fill factor should be is a very advanced topic, as a baseline, if you have a table that is frequently modified, consider setting the fill factor between 70 and 80. If a table is not updated too often, a fill factor of 90 should be sufficient. And something to note, fill factor can be set at the index level, but it can also be set at the server level. If you open the properties dialog box on the server and go to database settings, you can set the default index fill factor. Alright, now I want to talk to you about the pad index. It's tightly coupled with fill factor. This option has the same effects on pages in the index structures as fill factor, but instead of data pages, it controls how full the intermediate level pages will be. Unlike with fill factor, you cannot set a value for a pad underscore index. It inherits the value from fill factor. When an index is created, the data has to be sorted, and this requires the containing database to have sufficient space for this operation, which could cause performance problems. However, using the sort underscore in underscore tempdb option relocates the sort operations to tempdb. As a best practice, tempdb should be stored on a separate set of disks from other databases. Not only can doing this improve performance, but it also allows you to transfer disk space requirements to tempdb. So that's it for this tutorial. I look forward to seeing you in my next tutorial. Thanks for watching.